Olbrich. I have a small consultancy called PrimeLime. I wear a couple different hats. That's why Tony probably got tripped up a little bit. I have a few different jobs. One of them is I'm also an industry analyst with Signals Research Group, so you might see our report Signals Ahead. So myself and Mike T-Lander, we generate these reports based on industry trends. We just did a gigabit LTE report of our testing down in Telstra. In a couple of weeks, you'll see a report on the drone testing we did with LTE utilization for command and control of drones. And then I wear another hat with 5gcourses.com. So we've developed an online training course. You can go to 5gcourses.com, take a look at it. So that's kind of self-promotion from that aspect. But I have a few different hats I could wear, and it gives me a perspective on the industry. I've spent a lot of time in the research and development world at Qualcomm and Ericsson and base station development, and spent 7 years in the federal government at NIST creating the First Responders Network Authority. So I was in charge of R&D for that. You may have heard of FirstNet and their work with AT&T. So it allowed me to see all different aspects of the network, from the device side, transport, a radio access network, core network. And I've taken that now into a consulting role, and as part of that, we look at new technology trends and 5G. Obviously you're all here because of that. But I guess what I want to ask you is, what's different about this G? Why are we here? If I asked each one of you, I'd probably get different answers. Some of you might say, well, I'm really excited about millimeter wave. That's a big deal. Wider throughputs, or faster throughputs, wider bandwidths. But what really encompasses 5G? So if you look at kind of the genesis of that, the next generation mobile network operators got together and they created what 5G is. And they, you can read it here, and it's what they're saying is an end-to-end ecosystem to enable fully mobile and connected society that empowers value creation towards customers, partners, through existing and emerging use cases delivered with consistent experience and enabled by sustainable business models. You don't see any talk about short TTI, OFDMA, DFTS, or anything like that from NGMN. It didn't have any of those concepts in there. It was all about value creation and business aspects. Now, we'll talk about the radio layer here and physical layer. That's why you're here. That's why Rody is hosting that. But that's an important aspect to understand the genesis of 5G. It's not all about faster throughputs, even though that's what we like to talk about, and we will talk about that. It encompasses a whole lot of changes to the entire ecosystem. I think in the wireless world, though, our predictions of the future and of what our technology will be used for, they haven't been that good. If we would have listened to Winston Churchill, those who fail to learn from their history are doomed to repeat it. We kind of do that in the cellular industry, unfortunately. Those of you remember WAP, EVDO, it could have been EVDV, VoLTE came on as an afterthought, VMS. All these great ideas that we spent a lot of research and development on never really came to the full fruition that we thought it would, or they required a lot of changes to the standard. So we often build it and they will come. And from that aspect, we look at 4G, and when we put LTE out there, we had no idea that Uber and Lyft and all these other, Airbnb and all these other type of applications will become part of that. In 5G, though, we took a little different approach. And for those of you who have been involved in 5G, you've probably seen this triangle in a lot of different presentations. This is the ITU triangle of use cases that were developed for IMT 2020. So when operators and infrastructure and regulators got together and said, what will this new technology envelop? And they basically created 3 quadrants for that. The one that probably has the most interest is enhanced mobile broadband. So this is getting faster throughputs to allow applications such as virtual reality, augmented reality, really fast throughputs, streaming 8K, 4K video, things along that line. But limited mobility perhaps in those really high data throughput use cases. The other one is, well, we hear a lot about IoT and 50 billion connected devices, or however many devices, take your pick from whatever analyst you have. So we have massive machine tech communications, right? And that's, and you'll see MMTC, you just heard Tony say there's a demo out there. I suggest you go take a look at that. But you'll see how low-cost devices now don't have to operate on unlicensed bands like Zigbee and Wi-Fi. Now LTE has proven to be extensible for that with, Cat M1, Cat M2, going to LTE, or going to 5G. We take into account those type of things in the protocol to ensure that we can have short packet sizes, allow connectionless transmissions, so forth and so on. So 5G is going to encompass that. It's also going to encompass ultra-reliable low-latency communications. So for applications that need extremely low latency, V2X or vehicular-to-vehicular communications with short delays, ultra-reliable low-latency communications is part of it. So now we have a new frame structure to handle that. But is this really what 5G, what we're talking about today? Does it encompass that? Well, massive machine type communications, LTE is kind of handling that right now. So 5G will eventually get there. There's working standards bodies for it. Some of you might be looking at that right now. But really, it's the enhanced mobile broadband aspect that we're looking at. Ultra-reliable communications, well, that's part of it. Public safety might be part of that. Drones, V2X, that will come eventually. But again, it's enhanced mobile broadband. And we're going to hear in the presentation after this about what that looks like. What is it really enhanced mobile broadband? It's really wireless to the home. It's fixed wireless is really the first major application that's being utilized for 5G. So a lot of the things that were put forth by the ITU and by others to utilize 5G for, we're really not using those mobility aspects. Now, case in point, the Koreans are pushing millimeter wave and mobility for that in their demos for the Olympics. And this will eventually come. But our first steps as we come out of the mud and become erect and start to walk in this evolution is going to be a fixed wireless venture. And that's not necessarily a bad thing. So I'm going to ask you another question. Is it 5G or 5G? And what I mean by that is it a small G or a big G? For those of you that have been in the wireless industry, in about 2008, there was a lot of marketing campaigns that came out in 2009 with regards to HSPA, HSPA Plus, and the ability to offer 4G services. And so you saw a lot of mobile network operators start to sell 4G services when 4G wasn't even out. And so 2010 rolls around, those of you who with Verizon, you started to deploy LTE networks en masse, and that started to offer 4G capabilities. But not until really release 10 did we meet, quote, 4G metrics and things of that nature. But the marketing engine started. So earlier this year, I was in Barcelona at Mobile World Congress, and that same group of people, the NGMN group, Next Generation Mobile Network Operators, all the CTOs were lined up on the stage, about a dozen of them, and had an opportunity to talk to each one of them. And so one of the questions that was asked is, did we learn our lesson from LTE and HSPA and EVDO? Are we going to market LTE services as 5G, or are we going to wait until a 5G standard is put out there before we start selling it? And to a person, every single chief technology officer said, no, we're going to market LTE. If we see a competitive advantage, we will market LTE as 5G services. So we didn't necessarily learn anything from our history from that. Yesterday, the first shot across the bow of the consumers and taking advantage of their interest in technology happened. So yesterday, press release by AT&T said, in select markets of Austin, starting today, which was yesterday, AT&T is going to offer on the Samsung S8 5G evolution internet speeds. Fascinating, huh? Guess what? They even trademarked a symbol. 5G evolution. You're going to start seeing this marketing. You're laughing. This is happening now. It just happened. So it is being sold right now, 5G. You go buy an S8, you can get 5G. Here's more of their press release. 5G evolution in Austin is going to give customers a taste of the future. All right? What's interesting is that you don't have to wait to experience endless entertainment possibilities on the next generation network when you have the latest devices. Why did this come out? Why is 5G being, do they really have 5G? Is the S8, oh, if you look at, man, I'm going to go buy an S8. I don't care if the battery blows up. Oh my God, I'm not getting one, right? I can tell you this, it doesn't have the X50 chipset in it from Qualcomm, okay? It is not doing 5G in it, all right? There's a little disclaimer at the bottom right there. I put it up there. You can't read it. I made it small on purpose. What that disclaimer says is that you will eventually get 5G type speeds with the inclusion of more small cells, and densification, and 4-carrier aggregation, and 256 QAM. So putting those all together, you're going to get 5G-like speeds. So there's this disclaimer at the end of that. So that's interesting. So essentially, gigabit LTE. So I'm going to take, let's say, 4 spatial layers. I'm going to take maybe unlicensed band with LTE unlicensed or LAA. I'm going to aggregate that all together. I'm going to do a higher order modulation on the downlink, 256 QAM under really good signal-noise ratio conditions. And I'm going to get you a really good experience. It's going to get you gigabit LTE. And that's not necessarily a bad thing. But the marketing, right now, it's already out there. So consumers now will say, I have an S8, I have 5G. You're going to see that. You'll see this in marketing posters and all of that. But why? Well, this came out right after the earnings report of AT&T. If you look at AT&T's earnings report, smartphone sales are down. People are hanging on to their smartphones longer than expected, and that's across the board. T-Mobile, Sprint, Verizon have all reported their earnings. The smartphone sales didn't grow as much as they anticipated. Some of them were down. People are hanging on to them because your processors are pretty good. You have carrier aggregation on it. Your screen is HD, and it's pretty expensive. And if you're like me and have a couple teenagers, you don't want to buy them an S8 because they're going to crack the screen in about 3 minutes as soon as they get it. And I'm not going to pay another $1,000 for a phone or $800. So unfortunately, we're at the small G, but now I guess it's at 5 to the G power. Maybe it's a little bit higher. I don't know. We'll have to figure that out here. But anyway. It's already started with regards to the hype that you'll see around 5G. Luckily, you guys are working on the real 5G. So let's talk about what that vision looks like for what a 5th generation mobile network needs to be. So this is really taken from some of our training slides at 5G courses and extrapolated from NGMN. If you look, you hear this 1,000x more capacity. Qualcomm has been a big proponent of 1,000x capacity. Being able to offer that across the entire spectrum of coverage. So across all bands, across my entire coverage area, I want 1,000x more capacity and throughput. That's a big challenge to do, to get more bits per second per hertz out of what we have right now in LTE. So being able to offer gigabit access, having a software-based system. So kind of extrapolating the software functionality outside of the hardware. Getting to a nice layer 2 software-defined network and having switches in there that can be programmed in real time. That's all part of this 5G vision. Ubiquitous connectivity, so being able to have dual connectivity. So we talk about non-standalone and standalone iterations of 5G, having a standalone 5G system or a non-standalone system. You still got to merge that back at the radio layer. So how do you do that? What has to happen within the standard? And then a large range of applications. We talked about those 3 quadrants of the ITU triangle. So how do you have something that has to support, let's say, a 400 megahertz wide bandwidth here in the United States in the 28 to 29 gigahertz range, and support multiple bands, maybe in your cellular bands, maybe 3.5 gigahertz band, and then support low latency communications and really fast, 4K video. So having support for a large range of applications. This technology needs to be extensible to that. And then, we talk about the virtualization of that. So from the infrastructure and even from the device side, from the UE and CPE side, it needs to support all of these things. So enabling all of these things. Now, what's interesting is that they base this off of data rates of 2010. So NGMN said, okay, 5G standards, ITU, we're going to base it off 2010 standards. Remember what networks were in 2010. We had Release 8 coming out. We were, if you got 30 megabits per second on the downlink, you're really happy under ideal conditions in an unlimited cell. So the bar was set relatively low. I think we can achieve that and exceed that in many instances, at least from the throughput aspect. So let's talk then about physical layer LTE and what has to happen in that. So we have this amorphous, what is 5G? And like I said, if I talk to each one of you, I'd probably get a different answer of what encompasses 5G or what you think your thoughts are, what you're focusing on 5G. So the big elephant in the room, I'll just say, is millimeter wave. At least here in the United States, that is a primary focus of utilizing new spectrum for wide area communications. I mean, millimeter wave's been around a long time. Its use has been utilized for quite some time now in the United States for long haul communications and short haul, backhaul. But using it for wide area networks, it's a new concept. So in order to do that, we need a new PHY layer. So looking at new innovative schemes to do access in the network. So yes, it is OFDM. So we're using OFDM in kind of a different way. We have a scalable numerology. So, well, I guess from the Verizon aspect, you're looking at 75 kilohertz if you're from Verizon, but looking at the 3GPP, 5G instantiation of that, you have the scalable numerology, so we can scale across multiple bandwidths, so we can go from 15 to 30, 60, so forth, and so on, kilohertz subchannel spacing. And so we can offer maybe multiple access techniques. So you look at massive machine tech communications, different access methodologies are being looked at, RSMA and things of that nature. So those of you who have a CDMA background, that's actually going to come back into play for massive machine tech communications on the uplink. You're going to see non-orthogonal type access be put into 5G. And because of the frame structure of 5G, it allows a lot of flexibility in that. If you break apart the 5G frame structure, it allows new technologies to be inserted. We created blanking subframes in there. And you think, well, why do we put blanking subframes in there? It's to add in new technologies such as this, and to allow broadcast type communications or a new type of physical layer attribute to be added. Whereas in LTE, those middle 6 resource blocks are kind of stuck with these reference signals that are kind of shoved in the middle of it. And we thought, hey, this is a great idea. We'll always know where the reference signals are. But now we can't do much with that. We can't move it around really. In 5G, we have a lot of flexibility there. So because of that, we have a lot of flexibility. We have this wide bandwidth. Now I need to get my data out to my people. So, Claude Shannon was right. We're kind of at the Shannon limit with LTE. And so we added in more spatial layers. We changed the